Hi everyone, for this problem we're going to be looking at getting the net electric field at 0.40 due to two charges. So let's look at the 0.40, and we're going to be looking at the E field that's generated from each point charge. And something we should remember is that when we're looking at E fields due to a point charge, that if it's positive, it's going to be radiating from or away, and if it's negative, it's going to be the E field's going to be heading towards the charge. So you can look at the basically E fields, E field vectors that are due to the each point charge. So because we have to break this vector up into components, because when we're looking for the net, we want everything in the x, everything in the y, and I'm choosing to find this angle here. And we're given actually the distances 3 and 4, so I can find the relationship to find this angle. And this angle will help us find the components for this vector. So now you can actually see here's in the x, here's in the y, and when we're looking at the contribution from this point charge, it's actually all in the x direction. So let's start to account for the net E field in the x direction. In the x direction, we're looking for the contribution from E1, so which is going to be this right here, and then also from E2. So now let's look at this. This is the magnitude of E1, and I'm only interested in the x direction. And I'm actually going to write it as negative because this is pointing to the left, which is in the negative direction. And I'm doing that because I'm not going to include the different signs. So in this case, for Q2 it's positive, for Q1 it's negative, and so I don't want to plug in for the negative here. I just know that this is pointing to the left, which is in the negative direction. And so in the x hat, I have negative E1 cosine of theta, which is this component here, plus E2, which is actually all in the x to the right hand side. So that's going to be a positive E2. And there that should be it for that. So now for the y contribution, I'm actually only going to have only this component because E2 was all in the x, so there's no y for the contribution here. So I'm just going to write it's in the y hat direction, and it's positive E1 because we set going up as the positive direction, and sine is going to be this angle for sine. and that should be all for the Y. So looking for all of E net, it's going to be all of the X with the contributions from E1 and E2, and then the Y contributions from E1 and E2, which we found up here. So now we're just combining for the E net. So you can see E1 cosine, E2, E1 sine theta. So now let's actually solve for E1 and E2. So to find E1, we're going to be looking at this equation here, which is expressing the electric field due to a point charge at a specific point. In this equation, our R here is actually going to be the distance from the point charge to the point at which you're analyzing to find the E field. So which in our case it's going to be 5, which we found by just figuring out the triangle what the hypotenuse was. And for Q, that's just going to be what the charge is in coulombs. So with that information, we can start to fill out what E1 should be. The only thing that's missing is K, which is just the Coulomb's law constant, which is 9 times 10 to the 9. And you just fill in for the charge and then the distance. And that should yield what E1 is. And we should be able to use that later on. So now we do the same thing for E2, and we just plug in again, just a different charge here, and I believe the distance is different also. This yields what E2 is. So now when looking at E net, we can just plug in for E1 and E2, and I previously solved for the angle, and we just kind of plug those in to find out what the final X component is and what the final Y component of the net E field. Once you plug everything in, that's going to be the total E field at 0.04.